Hi everyone, this session is on some more questions relating to our topic on linear graphs. And they're questions that we may have not covered in class, and they're coming from your revision booklet anyway. So please make sure that you watch these and also mark them as we do them from your booklet. Now, if we have a look at question 7, we notice that these equations are different to our standard form. Okay, so we know that the general equation of a straight line is this: y equals mx plus c. Just to recap, we know m is the gradient, which is rise over run, or y over x, and c is simply the y-intercept. Now, when we're given a graph and we have a line that is diagonal, okay, so going in that direction, which is positive, or it can be going the other way, which is negative. If I draw another line going down this way, it's a negative. Lines that are like this will always be in this form. Sometimes C is 0, okay, but you always have a gradient, and you always have y and c and x, okay, in the equation. But these ones here, you notice that with question 7, we only have a y in this one. Y equals a number, and here we only have an x. When you see that, it's telling you your line will either be will either be vertical or it will be horizontal, okay? When we have these lines, they are an exception. That's where you only have a y or you only have an x, depending on what you have. So if I have a look at these questions here, it tells me y is equal to -4. That's saying y is only -4. So to draw it, it's really easy. So I'll draw my axes. There's y and x. So to draw it, or the question says sketch. So sketch means you don't actually have to do a scale. You just, with these ones, you're showing one point. So the question is, draw this, y equals -4. This is all you have to do. Because y is only -4, go to the y-axis and pretend -4 is down here. There it is. There's -4. Like I said, it doesn't matter where it is because you've only got one point. And because y is only -4, your line is going to be a horizontal line going through -4. Sorry, it's not. I'll try again. That's really bad. It's a bit hard on this. Going through -4, and that's it. So with this, y can only be -4. It can't be anything else. X can be 1, it can be 2, it can be 3, or negative. X can be anything. It will hit the line. But y is stuck being -4. Okay? And that's it. So if you're given a question that asks you to do the opposite, so for example, if you have this, if you're given a graph, and I'll put a line up here, and I'm telling you this point here is +3. And if the question says, what is the equation of this line? Because it's horizontal, y can only be +3. And that's it. So sometimes you'll be asked to draw it. Sometimes you'll be asked to find the equation. So it's really easy. So if you're given one with x, so 7b had x in there. And it had, so b was x can only be +3. So once again, you quickly draw your axes. And this time, x is on the positive end. We know positive is here. Put 3 wherever you want. It doesn't actually matter. It can be there or anywhere. That's one point we're drawing. And because x can only be 3, it's going to be a vertical line. And that's it. X is stuck being 3. Y can be anything else. Y can be +3, 2, 1, or minus. Y will hit the line anywhere. But x is stuck being 3. Okay? And just to make sure you've got it, what is the equation of this line here? I'll draw another graph. And this time, I'm giving you, hope that came out thicker. I'm giving you a line. Here it is. Oops, sorry, it's supposed to be passing through there. So it's passing through the point where x is -2. What is the equation of that line there? Okay, quickly write it down, and you should get, I'll just change the thickness. There we go. Because x is stuck being -2, x can only be -2, and we're done. So remember, whenever you have a vertical line or a horizontal line, It's either y is equal to this or x is equal to that. So keep that in mind. Now I'm going to try and do question 8 and 9. 9 might be a bit challenging because I haven't got graph paper, so I'll try and find some. But with question 8, it tells us to draw the following linear equation using the x and y intercept method. So we know with this method, we have to find 2 points. Now with 8b, it asks us, does this method require the linear equation to be in this form? Well, no, it doesn't, because I don't need to know what the gradient is or the y-intercept. I just make x equals 0 and y equals 0 and I'm done. Okay? So you should have watched a lesson on this as well. We have done it in class, but I know some of you were away that day because you had sport. So using this method, the x and y intercept method, it's important that you use this method to show you understand how to use it. There are 3 methods when drawing a graph. Okay? And this is the second one that we've learned. So to do this, there are 2 steps. Okay? Your first step is find the y-intercept, and with this one, you can see what it is. The y-intercept is -4, but find the y-intercept when x is 0. That's your first step. Your second step, find the x-intercept when y is 0. And that's it. Okay? And we know that the y-intercept is when x is 0, and we know that the x-intercept is always when y equals 0. So please make sure you've watched that lesson in case you're still not sure. So when x is 0, so when x equals 0, put it in our equation, there's x. We will have y equals 2 times 0, and we do that first, and then -4. 2 times 0 is just 0, so we're left with y equals a -4. That's why the y-intercept is always c, always that number at the end, because if x is 0, you're always stuck with that number. Easy. And that's the point we have found. When x is 0, y is -4. And the second step is find the x-intercept when y is 0. So there's y in the equation. So we should say when y is 0, it's important to explain to the person or your teacher what you're doing. So when y is 0, we've got 0 equals 2x minus 4. You can rewrite the equation if you want to. So you have 2x minus 4 equals 0. If you want x on this side, minus 4, so we've got 2x. So opposite of -4 is to +4, +4. Almost there. I'll squeeze it up here. Divide by 2. So x will equal 4 divided by 2 is 2. And we're done. So this point is when x is 2, y is 0. And your final step is to plot these 2 points on a graph. You don't need a scale for this, and you're done. So I'll make some room on top. I'll just draw a mini graph. So please make sure you use a pencil and a ruler. Okay. So now we don't need to do a scale. So when our y-intercept was when x is 0, y is -4. So it can just be here. There's -4. There's 1 point right in the line. That's when x is 0. And here, when y is 0, x is +2. So I can say 2 is over here if I want to. Doesn't actually matter. There it is. And your final step is to then, your line passes through those 2 points. And we're done. We can see we have a positive gradient, and our equation had a positive gradient, so it looks pretty accurate. And so like I said, with this method, you don't need a scale. You just need to plot those 2 points. But of course, use a ruler. And make sure you write down the points as well. Here it's -4, y is -4, and x is 2. It's important to show those numbers. Now, the next question that I really want to do is question 10, because we haven't had a chance to do this in class before I left. Now, using a table of values, we can use a table of values to draw any type of graph. It can be a straight line, can be a curved line like a parabola. If you look at this equation here, we know straight away it is not going to give us a straight line because the power of x is what? 2. We know the powers of y and x have to be a positive one, otherwise we won't have a straight line. And just before we do this question, if we go to question 1, where is it? That was the question we started off with. Circle the equations that are linear equations that will give us a straight line. Okay, so just to mark this off, A was a straight line because y and x are power 1. B was not a straight line because the power of x is 2, not 1. C is a straight line because x and 1 have a power 1. That 2, that's 6 squared, is just saying 36. So that is a straight line. D is not a straight line because the power of x is a negative 1. It has to be a positive 1. And E, if I expand this, I have y equals 2x plus 16. So yes, this is also a straight line because y and x will have a power of 1. Okay, so question 1, you should have done that already. So if I go back to my graph down here, straight away I know this will not give me a straight line. So I'm going to use this equation to fill in my table of values. Now remember, it's really important to substitute with brackets. Otherwise, you'll make a mistake with this. So let's do this one together. So here's our equation. So here's our equation and our table of values. So they've given you the values they want you to use for this table of values. So all you have to do is this. This is how easy it is. Remember, you must substitute with brackets, okay? So when x, so your first one is when x is what, minus 2, you put it in this equation here. So when x is minus 2, we have y equals, instead of x, put it in brackets, minus 2 squared. On your calculators, you must push brackets and then minus 2 squared. Because with brackets, we're saying minus 2 times minus 2, which is a positive 4. We have gone through this many times. Okay, because the brackets are there, it's saying 2 times 2, but also 2 negatives. So 2 negatives. If you had no brackets, if you had this minus 2 squared, put that into your calculator, it gives you a negative 4. It's saying 2 times 2 is 4, but there is just one negative. That square doesn't belong to the negative, only to the 2. Brackets, it belongs to the 2 and also to the negative. So please be very careful, otherwise this will be wrong. So y equals, in brackets, minus 2 squared, we get a positive 4. So in that table of values, put a positive 4. Done. Next one, when x is negative 1, sub it into the equation. Instead of x, we have y equals minus 1 squared. Minus 1 times minus 1 is positive 1. And we've got a 1 there. Done. And you can do this without working out. When x is 0, we've got y equals 0 squared. 0 times 0 is just 0. Okay? Now be very careful. I forgot to mention, you know with a straight line how we usually continue the pattern. So to get from 4 to 1, we minus 3. You cannot do this with this equation. Okay? This is not a straight line. It's got a power 2. There is no pattern with this. Well, there is a pattern, but it's different to what we've been doing. So you cannot do this. From that to that, go minus 3. Do not do that with these equations. Only do it when you know you have a straight line or a linear equation. Okay, keep that in mind. All right, and now when x is positive 1, so we can make more room. So you can pretty much do the rest yourself, but have a go first with the rest. So when x is positive 1, we have y equals 1 squared. 1 times 1 is just 1. Oops. And last one, when x is 2, we've got y equals 2 squared. 2 squared is just 4. Okay? And that's it. We've filled in our table of values. Now all you have to do is plot each of these points on a graph and you're done. So I'll just make some more room. Alright, so I managed to put a graph in for this one because I need it. Now, all we're going to do now is plot these points. We've filled in our table of values and plot these points on a graph and join them up to see what we get. So when x is minus 2, remember this is a point. When x is minus 2, y is 4. So x is minus 2, there it is, y is positive 4. That's my first point. Next, when x is minus 1, y is positive 1. There it is. 0, 0, that's the origin. When x is 1, y is 1. X is 1, y is 1. And when x is 2, y is 4. And you can see how we do not have a straight line. This is what we call a parabola. So instead of joining them with straight lines, try and do a bit of a curve. Whoops. This works. Do a bit of a curve, just like that, and you're done. That's the equation of a line, of an equation where you got a power 2. So whenever you see a power 2 next to the x, it'll always have a curved parabola somehow, okay? So keep in mind that it's important when you substitute, you use brackets. And you can use a table of values to draw anything. If you want more of a challenge, I want you to go ahead and try this one. What happens if you've got an equation like this? Y equals x to the power of 3 instead of x to the power of 2. Try this one here, because that may be on your test. Using a table of values, you can put in the same values, -2, -1, 0, 1, 2, and see what kind of graph you get. And of course, you can use an online graphics calculator to check your graph. The last question that I want to do is question 9. Sketch the following linear equation using the gradient and y-intercept method. So you should have watched the video on this, and it's actually a fun method, pretty straightforward once you understand what to do. And with question B, it says, does this method require the linear equation to be in this form? Yes, it does. To use this method, we have to see what the gradient is and the rise and run. So this one has a rise of 1 and a run of 2. And the y-intercept, which is our starting point, is -5. So this, for B, you should have answered yes. Okay, so using the gradient and the y-intercept method, first step is, starting point is the y-intercept. The y-intercept is -5. I go down to -5. That is my first point for this straight line. Okay? Now, before I draw this, is my gradient positive or negative? It's a positive gradient, so I should be going up the hill, which means going up that way. So I know my line has to go up that way. So just keep that in mind as well. Now, so I've got a half, 1/2, that's my rise, and that's my run. So that means because it's a positive gradient, we're going up instead of down. So we know that it's positive. We go up 1 and across 2. And when we go across, we always go to the right with our run. Whether the gradient is positive or negative, always, whenever you're starting off, go to the right with your run. The rise might be going down if it's negative, that's all. So rise up and then go across 2. 1, 2, that's your next point. And continue. Rise up 1, across 2. 1, 2. Up 1, across 2. And I'll stop there because I've got no more line paper on my graph. And that's it. Okay? You can pretty much draw in this line, but I want you to also go in the other direction. So do the opposite to go in the other direction. Instead of going up now, we go down 1. And instead of to the right, we go to the left 2. 1, 2. Down 1, and then 1, 2. And you can keep going, but we've got no more graph paper left. Oops, sorry. It's a bit frozen. And now your final step is to join these points up using a ruler. So imagine I got a ruler, and they should give you a straight line. Okay, that's how easy it is to use this method. So remember, when you're starting off, you either go up or down, depending if your gradient is positive or negative, but your run, always start off by going to the right. When you do the opposite, you go to the left. Okay? So hopefully that has helped a little bit. And please make sure you mark the rest with the partner. Thank you.